So this is a scheduling program. So the scheduler, also called as a dispatcher, it is a part of a kernel responsibility for the determining which task will run next. Most of the real-time kernels are the priority based. Each task is assigned by the priority based on its importance. The priority for each task is application specific. When the highest priority task gets the CPU, however, it is determined by the type of a kernel used. There are two types of a priority based kernels, that is non-primitive and primitive. Scheduler is responsible for the time sharing for the CPU among the tasks, where because means the RTOs are the different performance characteristics. There is the challenges for the RTOs. GPO's maximum average throughput output. RTOs deterministic behavior. A theoretical optimal schedule does not exist. Hard to get complete knowledge, task requirements and hard properties. The requirements can be dynamic, depends upon the varying of time. Non-real the time systems usually non-primitive scheduling. Only a task starts scheduling, it completes a full execution. Most RTOs performs priority-based primitive task scheduling. Basic rules for the primitive-based primitive task scheduling. The priority-based primitive task scheduling happens by the three things. Every task in the software application is assigned a priority, high priority which depends upon the higher need to be a quick response, follow needed. The static priority, the next topic is static priority and the dynamic priority. Static priority which has to be a stable and it is to be very simple. It is created to keep the things priority during the whole lifetime. The scheduler is very simple because it looks like a white queues of an each priority level and starts the task in the higher priority to run. Dynamic priority. The scheduler becomes more complex because it has to calculate task priority on the line based on the dynamically changed parameter. The earliest deadline of an EDF, the task closer deadlines to get higher priority. This is the timeline of an preparatory of an primitive scheduling. The task switch determine when the currently running task should not continue to run. Why it is to be in the queuing stage. If it is in the queuing stage, it goes to the task switch. It will. This software is the software triggers. It shall go through the following steps of a task switching. The first thing is determine which the task should not run next. Say the environmental of a task that was to be stopped. Set up the run environmental of the task that will not run next. Allow the selected task to run. A non-real-time operating system might do task switching only a timer thickness. Even it primitive schedulers, a large array of a task is searched before a task switch. This is a graph representation of number of the tasks can be scheduled and using the real-time systems. So this is the task schedulability. New task is coming. Permissions, running, dispatching and the termination. The schedule is in the order list of a task. A queue or the task is scheduled if there is exist and schedule, so no may fail to meet. Thank you.